Here we go, exercise 5C. What we're now going to do is that line, A plus A plus A plus A plus B plus B, there has to be a shorter way of writing it because it's just too long. Now, here's the logic. If I asked you A plus A plus A plus A, how many A's do you already see there? Yes, Ashwin? 4A. So we can say this is the same thing as saying 4 groups of A, or 4 times A, because I know I've got 4 of them, right? Now notice that I had to write a 4 in front of A to say that I've got 4 A's, but notice that the letter A itself, I didn't have to write the 1. Because we're too lazy. There was no need to write the 1. We all knew it was 1A just by having the letter itself. That was already 1A. Yeah, but you can write the 1 if you want to. As mathematicians, we're just too lazy to write that. Okay? So that's why you know if you've got 1A plus another A plus another 1A plus another 1A, well in total I've got 4A, or 4 groups of A. Okay? Whereas on this side, what is B plus B simplified to? Yes, Ashwin again. 2B. So this is 2 groups of B. Now notice, we can't add these 2 together because they are different groups. A plus A plus A plus A, at least I can say they're the same groups. I can put them together. And then this is the same group, I can put them together. So, why is that the case? I often, and I don't like to do it, but I think it's a way for you to understand as well. I don't like to contrast algebra with fruits, but if you think about the language and logic, it makes sense as well. If I said A represents apples, an apple, then what I'm saying there is I've got an apple plus another apple plus another apple plus another apple. And then let's say B was banana. So B represents a banana. Then it makes sense that in total I've got 4 apples and 2 bananas. What doesn't make sense, if I then say I've got 4 plus 2, which is 6 AB, that doesn't make sense. Because now I'm either saying I've got 6 apples, which I don't, I only got 4 of them, or I'm saying 6 bananas, which again doesn't make sense because I don't. I only got 2 bananas. So that 6AB is what I often see students do when they first start practicing algebra. They confuse the two. Okay, so you have to think of it in terms of groups. It's kind of like the chairs. If I asked you how many chairs are there, you would count all the chairs. But if I asked you how many of these grey, bluish chairs there are, you would actually go and look for the grey. You don't count the greens. Get me? So you look for the ones that are actually the same. Same thing with algebra. When we group them, we only look for the ones that are the same. Okay? So, in this case, do not write your answer as 6AB. That is wrong. The best thing you can do is just leave it as 4A plus 2B. Now, some of you might say, like, well, there's not much difference between the first line and the second line. It does matter if I asked you to write 99A plus 200B. So you don't want to sit there and write A plus A plus A 99 times and then plus 200 B's, B plus B plus B plus B. It takes too long. This is more concise, right? So that's what you're learning to do. You're learning to take a really big expression and condense it. That's what 5C is doing. Yeah, so that's one of the first skills. Let's do an example. Let's scroll down past that one. Let's go to this one. All right, so let's practice the first example. In this expression, let's revise your exercise 5A stuff. How many terms are there in this expression? Can I please have... Let's go with, who have I chosen? Let's go with Colleen. How many terms are there in this expression? 3. Very good. For those who haven't done 5A yet, you count it by finding where the plus and minus signs are. They separate how many terms there are. So you've got 1 term, that's 3A. You've got 2A, that's your second term. And then you've got your third one, that's 4AB, right? So out of those 3 terms, which ones are the same? Which ones have the same group? Which ones are the same types of grouping, Kyle? 3A. Very good. 3A and 2A. Now I know this has an A as well, but notice it's an AB. Okay? This AB, even though it has an A, they're actually different groups. Kind of like you guys. You guys are students. So it's kind of like students, S, S, and an S. But then not all students are the same. You're students of 8D, and then there's students from 8E. You wouldn't group them together. They're different groups. So you're both students, but then there's a more level difference between the students. Or if we think about apples, this could be apples, normal apples, and then maybe when you have a B, it's a bruised apple. So bruised apples are not the same as normal apples. Okay, so you have to find the same groups to group them together. So in this case here, how do I simplify this expression? Instead of having 3 terms, it was easier to group this together and say, well, 3a plus 2a, notice that they both have the same groups. 3a plus 2a can be simplified down to what can I please have? Let's go with Liam. What's 3a plus 2a? That makes 5a. Very good. So together, that makes 5a. And for those who don't understand why it's 5a, again, 3 times a just means, so I'm just going to write here 5a. Remember, 3a just means a plus a plus a. And then 2a just means plus another 2a. So if you count it all together, it makes sense. A plus a plus a plus a plus a. That's 5 of them there. Okay, so that's what 2a and 3a represents. All right. So now I've got 5a and then I've got plus 4ab. You cannot add those two groups together. One is a normal apple and one is a bruised apple. They're not the same. Okay, so I don't like to think of it in terms of fruits, but in this context, you can see the difference between the two. So I've got, thank you. I've got 4 bruised apples. And I've got 5 normal apples. That's why you can't group them together, say it's 9 apples. They're different. Okay? That's how you simplify for the first one. Now let's scroll back. So what we've done there is we went from 3 terms down to only 2 terms. Notice there's only 2 there. Okay, so there's 5a, 4ab, 2 terms. So we went from 3 down to 2. Now your last part of the skill is your textbook likes to switch the letters around. So notice the first group. ABC. ABC and CBA at first glance looks like they're different. But if we break it apart and actually understand what ABC means, now let's think about it. When you write a 2 next to an A, that means 2 times A. Okay, we're just too lazy to write the times because it's 2 groups of A. What do you think A next to a B and then next to a C actually means? Let's go with Tom. What do you think is in between? What's happening between A and B and the B and C? Times, just like this one. So between the 2 and the A, you write 2 next to an A, it means times in between. Well, same thing with letters. A next to a B would mean A times B, and B next to C means B times C. So if you break it apart, this actually means A times B times C. But then if you look at the second one, CBA, what does that mean, man? What does this mean? Yeah, C times B times A. Now, at first glance, they look different. But if you think about it logically, when you multiply numbers, if I gave you 1 times 2 times 3 in that order, what's 1 times 2 times 3? Can I please have, let's go with Wendy. What's 1 times 2 times 3?
9.
6. 6, you were right the first time. 1 times 2 is 2, and then 2 times 3 is 6. Yeah? Good. Now, 1 times 2 times 3 is 6, but if I swap the order, 3 times 1 times 2. Hey, Bo, you just wait till I finish it. Big race. I'm just explaining this a bit. 3 times 1 times 2. Notice even though I swapped the order there, 3 times 1 times 2 is still 6. That means when it comes to multiplication, it actually doesn't matter about the order of the lettering. ABC is actually the same as CBA. So that's why, even though they swap the ordering, you still have only 1A, you only have 1B, and you only have 1C. So they're technically still the same group. Okay, they're still the same exact group. So why do you need to know that? Because your textbooks love to switch the letters up to trick you. So here's an example of it. Let's have a look at this one. How many terms are there in this expression? So this is an expression. How many terms can you see? Very good. So you can see that this is 1 term separated by a plus sign, 2 terms separated by a plus sign, 3 terms separated by a plus sign again. So you got 3 of them. Now at first glance, they all look different. I've got a CD, then I've got a DC, then I've got a C squared D. So they all look different. But actually, CD means C times D, And DC actually means D times C. I've got 1C and I've got a 1D. These two are actually the same groups, even though they look different. So, these two are the same groups. This is not. That actually means C times D. That one is different. Okay, so these two are different. One's D times C. This one's C times D. So if you add them together, which groups can you group together? You can do 2CD plus, and I personally like to change that DC, change it back to CD just to make it easier for you to see that they're actually the same. So 2CD plus 4CD plus 6C squared D. And those two you can add together. What's 2CD plus 4CD? Can I please have, when I chose Leon? What's 2CD plus 4CD? 6 of these CDs. Very good. Plus 6C squared D. And remember, you cannot add these two together because one has 1C and a 1D, but the other one has C squared and 1D. They're totally different. So you have to leave your answers there. Don't add them together. Okay? So far, so good. So it's two skills. You're looking for the same groups and you're simplifying them down. Here's the last one. I'm going to give you 90 seconds. And I want you to get this answer here. That's a minus yx squared there. I'm just going to write it all in one line. 90 seconds. Let's go. I'm going to put on a timer. 90 seconds. And here we go. I want you to simplify it. So there are 4 terms. There's an xy, 2yx, 2x squared y, and minus yx squared. There are 4 terms. We can simplify this. Make it smaller. First, identify which terms are the same. We call those like terms. Twenty more seconds. And time's up. All right, let's go. So how do we break this down? We got to first find like terms. Which 2 terms are the same? Can I please have Wendy? Which 2 are the same?
1, 2.
1 and 2. So you got xy and yx. Yes, again, there's 1x and 1y in both of those groups there. So I normally like to rewrite them so they're in the same order. So xy, alphabetical order, plus 2xy. Yes, these 2 are the same groups. Remember, when you don't see a number, it's actually 1. So you've got one of these xy's. So 1 xy plus another 2 of those xy's. Whereas the next one, this is different. This is x squared y. And yes, this, even though it says yx squared, notice one has 1x squared and they also have 1y. So technically, these 2 are the same groups as well. So here we can then write that's 2 plus 2x squared y minus x squared y. So these 2 are the same groups, x squared y and x squared y, because the orders you can swap. So together, let's simplify it now. These 2 are the same. So 1xy plus 2xy simplifies to how many xy's, Mandy? How many xy's? 1xy plus another 2xy's gives me 3xy. So 3xy plus, now let's work out this one. How many of these x squared y's do I have? I've got 2 and a minus 1 of those x squared y's. So together I have 1. Now you can write 1 x squared y, but mathematically we're too lazy. we just write x squared y. You cannot add those two together because they are different groups. They are not the same. Yes, they have an x and a y, but one's an x squared and the other one isn't. Okay, so they're not the same. So your final answer is exactly that, 3xy plus x squared y. How's that feel? Pretty good? Because that's the first 6 questions of the fluency section of your exercise 5C. Okay, so I'm going to give you 20 minutes like I gave to the other class. I'm going to pause the video. After 20 minutes, we'll come back to do a problem-solving question on the back. So on the back, there's more questions here. But right now, I just want you to practice these skills here. Okay, so here's your textbook if you don't have it readily available for you. First 6 questions, 2 to 6. I want you to do exercise 5C. First 6 questions, 2 to 6. 2 to 6. And it's recording again. So here we go, problem-solving reasoning. So once you've done your fluency section of 5C, the next bit is then to apply your understanding. Okay, so why is it beneficial to simplify? And I showed it to the other class. The other class actually took a longer method to do it when they actually did the hard work to simplify. And I'm going to show you what I mean through this example. Say you've got a rectangle. Okay, what's the side that's the longest side of a rectangle called? What's that one called? Length. Very good. Length is usually meant for the side that is the longer side. And then the shorter side, what is that one called? Width. Very good. So in short, I'm going to call this capital L for length, W for width. Okay? Now, the question is asking, write an expression for perimeter. What does the perimeter mean? Can I please have Tilly? What does perimeter mean? Perimeter of a rectangle. What does perimeter mean? Do you know? Something else. That's the area.
It's the measurement around the outside of the shape.
Very good, but don't call us silly next time. But what you said is correct. What Bo said, it's the measurement. Perimeter means the outside distance of a particular shape. So hypothetically, if I was this person standing on that particular corner, if I were to walk around and see what the perimeter of the shape is, I'd have to walk one width down, then I'd have to walk one length across, then I have to walk again, another width up, and then I have to walk back another length. So in total, my perimeter, if I want to work it out, it would have been walk one width, walk one length, plus walk one width, plus walk one length.
So 2W plus 2L.
Very good. So this is where we've learnt to simplify our expressions. We've learnt that W plus W is 2W and L plus L is 2L. But notice the question. What is my length equal to? It is L, but notice there on the diagram it actually says 6x. That's how far it is. So what I can do is using my exercise 5B, I can replace each L with a 6x. And if you look at the width, so the width is 3x length. So that means each one now can be replaced. Now, why do I want to replace those letters? Why didn't I keep it as W and L's? What's the reason why we like it all in the same X variable? Why is that useful? Very good, because the benefit of having the same terms or same like terms, we can simplify that. So 2W and 2L wasn't bad, but that was still two terms. This one can be simplified. Shh, shh, shh. Thank you. Don't speak while I'm speaking. Thanks, team. It's disrespectful. 3x plus 6x plus 3x plus 6x. They're all like terms because they all have an x. So what's 3x plus 6x plus another 3x plus another 6x? What does that give me a total of, man? Is it 12? No. 18, because 3 plus 6 is 9, and then 3 plus 6 again is 9. So together, it is 18x. Now I'm going to use the letter P for the perimeter. So, we've got an expression. This is called an expression, but that's a simplified expression. It was better than writing 3x plus 6x plus 3x plus 6x, and is also better than writing just 2w plus 2l, because you only need to know what x is now. Okay? Now let's answer the question. First part of the question. B. It asks us, well, what if x is equal to 2? Okay, so what if you did know what x was? And let's say x was 2. Then what would the length equal to? And what would the width equal to? Because it's asking you what would the length and what would the width of the rectangle be? Now we said that length is 6x and we said that w is 3x. So what would the length and w or width be in this case here? If x was 2, what would the length be? So look at that question there. If length is 6x, yes, Lucas? Sorry, I thought you had your hand up. Not sure. Oh, did you need notes? 5C for today. What's the length? 12. And how do we get 12? Because 6x just means 6 times x. But since we know that x is equal to 2, we're saying that what if x was 2? Then it's really just asking 6 times 2, which is 12. Then what if I ask, what is the width? Width 3x means 3 times x. But if x was 2, then this would be 3 times 2, which is 6. So that means your rectangle is now 12. This is 6. Now if I ask you what the perimeter is, I'm going to zoom out. What would the perimeter be? If I know now length is 12, width is 6, what's the perimeter? What would you do? How would you calculate it?
Can I get a 3?
Yes, you can. How would you calculate, Ava? Yes. Now notice here, this is where the benefit of learning how to simplify expressions. The other class did 6 plus 12 plus 6 plus 12, and some of them added them wrong. But what was a quicker way than just doing 6 plus 12 plus 6 plus 12? What's a quicker way? Yeah, just right here. That was the formula. Why do we do these expressions? So you're problem solving. 18x means that as soon as you know what x is, 18 times whatever x is will tell you what perimeter is. Now, what was the benefit? Why are we doing this? Because that's what you're doing. If you did 12 plus 6 plus 6 plus 12, you're doing 3x plus 6x plus 3x plus 6x. You're doing a harder work. When the simpler work, you already did it. You said it's 18 x's together. So once you know x is 2, well, 18 times 2 is just doubling 18. So what's the perimeter? What's double of 18? 36. Okay, so that's the quicker way, and that's the benefit when you're doing these algebra. It's not just doing it for the sake of doing it. It's problem solving. It's why is it useful for you, and how can you simplify your problem? How do you make this? That's a small problem, but in reality, when you're building these sort of volumes and all that, there's a lot of things that come into play. So each letter represents a height, width, length. You can talk about three-dimensional shape or a sphere. The problems get harder. So when it gets too hard, you don't want to be doing that. That takes too long. Even a computer has to find its quicker way to solve the problem. So that's what we do. We do mathematics to be more efficient and more accurate. That's what that's for. Okay? Before I ask the last question, Kyle? Yeah, I was just adding on. So I added on another question to get them to see how does that link to this bit. Okay? Now C, the last part of the question. The other class couldn't answer it. Let's see if you guys can answer it. Why is it possible that x can be 2, but x cannot be negative 2? Someone explain it to me. Because we said x can be any number, so why can't it be negative 2? What's the problem? Kyle. Beautiful. You're the first to answer it so quickly. Logically, see, mathematically, number-wise, doesn't have a problem. But in application, when you're problem solving in the real world, well, yeah, there is a problem. How is it possible that if you put in negative 2, 6 times negative 2 would give you negative 12? So how do you even measure negative 12 centimeters length? Doesn't make sense. So in the real world, you can't have negative length, you can't have negative area, you can't have negative perimeter. That's why this answer here, even though it still works, you can still do L equals 6 times negative 2 and get negative 12, but this does not mean anything in the real world. So at my year 12 level, their answers, they have to note there are certain problems that don't exist. So in this case, they have to realize that's not possible. So here's an example of one of my year 12 answers that I'm going through. If you look at this one, look at the year 12s. Can you see this bit? See, it's question, method, answer. Problem equals vertical layout that I'm teaching you guys to do. But they actually end up with two answers. There's one's negative 50 and the other one's 10. But logically, centimeters cannot be negative. So they had to say W had to be greater than 10 or greater than 0. It's positive. That's why it can't be negative 50, and hence they get an answer. Right? This is the logical problem. If you zoom out, they were actually doing a serial box problem. They're working out the maximum volume of a box based on the length, width, and other things like what's the maximum volume you can have if your length can only be 2 centimeters. Hypothetically. Okay, so that application that you're applying, the method is key first. That's why I keep saying your exercises are one question, method, answer. The year 12 level, that's what we're applying to. We're doing things just problem solve. Yeah? All right, so that's for the problem solving and reasoning. So if you do get to that point on your textbook, so if you go here, let's go back to 5C textbook. If you go back to this one, the first 6 question is fluency. So just learning how to group things together. Problem solving onwards is where you start applying. You start to think about, well, how's the maths work? Okay? So I'm looking for minimum fluency. So you have to do the fluency first. This one I want you guys to work towards. Yeah, that's how you apply. I'll stop the video there.